we are on page 798, and we're going to take a look at number 8 at the top of the page under the higher order thinking problems and find the error. So this is just going to review what we did on Friday last week before we head into the second half of this lesson. So number 8 says you have a survey of a seventh grade class showed that 4 out of every 10 students, so let me underline that, 4 out of every 10 are taking a trip during spring break. And so there are 150 students in 7th grade. And Caitlin is trying to determine how many of the 7th grade students can be expected to take a trip during spring break and find her mistake and correct it. So take a look at what Caitlin is doing over here for the work. She set a proportion up like we practiced last week in lesson 1. And she's trying to solve and find out how many students out of 150 can we predict are going to go on this spring break trip based on the sample that was taken at the survey, 4 out of 10 students. So take a look at how she has it set up and see if you can determine the error in what she has set up in the proportion. So if you have to, pause, maybe discuss with a seat partner or in your pod or out loud in your crew, and decide which one or why it is set up incorrectly. And then pause the video. And when you think you got it, unpause and we'll talk about it. Okay. So I hope you saw that when she solved it, it said X equals 375 students. So that right there should be a red flag. Remember, there's only 150 students in the 7th grade. And so if you look at how she's solving and getting 375, you got to think, well, that can't be possible because I'm looking for out of 150, and 375 is higher than that, right? So look at the setup. She's got the 4 out of the 10 based on the sample that she took, the survey. And notice where she's putting the 150 students in 7th grade. That shouldn't be in the numerator. When we set our proportions up last week, we talked about how the totals need to be in the denominator. And that 150 is a total. So that needs to come in the denominator. You need to flip that second fraction. So it should say X over 150. So let's correct that mistake right now. So the 4 out of 10, the sample, absolutely, that was done correctly first. Okay. 4 out of 10 students in her survey said that they were going to take a trip during spring break. Now, if we flip this over, okay, there's 150 students in 7th grade. Remember, we talked again about the totals go in the denominator. So we want to know how many X on the top out of 150 is going to go on that trip. We're predicting based on a larger population. So we talked about a few different ways to solve this. I said one way you could look at is how much larger is it getting? You know, like in the denominator here, you're going from 10 people in the survey, 10 students, to now 150 students. So I hope that you see that this is getting 15 times bigger here. So that means in the numerator, you're also going to get 15 times bigger. And so when you do that, 15 times 4 to make this equivalent, you have 60 students. And so that makes more sense that you have 60 students out of 150 that are going to go on that trip. You're predicting, right? So we look at the first initial survey, the sample, we use that to then predict based on a larger population, and you can get an idea by predicting how many will go. Okay, so her error basically again was that second fraction was just set up incorrectly. Those totals have to go in the denominator. So that's what we worked through on Friday. Now, we're going to take a look at some percentages with predictions. So we're now going to go back and we're going to take a look on page 796. So let me get that page in front of you here. And we're going to take a look. We're in the guided practice on 796. And on Friday last week, we had done 1 through 5. Now we're going to take a look at number 6. So sometimes you're going to be given, let's say, a circle graph like you see here in number 6, instead of a table that you see that we started with on Friday at the top here. And so if we're dealt with a circle graph, which has percentages in those pie pieces, we have to use those percentages to help us predict. So let's read the story in number 6. Use the circle graph that shows the results of a poll to which 60,000 teens responded. 60,000 teens. So predict how many of the approximately 28 million teens in the United States would buy a music CD if they were given $20. So take a look at this circle graph. It says, how would you spend a gift of $20? And it's divided out, right? How, if they surveyed 60,000 teens, where they would spend that $20 gift. Now, specifically, it says a music CD. So we're going to take a look here in this teal colored section. And 32% of those 60,000 teens responded that they would use the $20 to buy that music CD. Now, the next thing that we're going to take a look at is, well, we need to predict. There's 28 million teens in the United States. This survey was based on 60,000 teens. That was their sample, their survey. Even though 60,000 is a big number, that was actually their smaller amount. That was their sample compared to the 28 million teens in the US. Obviously, that's the population. So now we're going to take and predict using this percentage. Now, 32%. This goes back to 5th or 6th grade, probably 6th grade, where you're changing your decimal or percents to a decimal, So you're moving it 2 places to the left, and you're going to use the decimal format of that percent, and you're going to multiply it by this 28 million teens. Now, again, we're not setting a proportion up this time because, well, we don't know the exact numbers in each of these pie pieces. What we do have is just a percentage of those teens for each section. And so we have to use that percent to predict. There we go. So 0.32, 32 hundredths times. And so we're actually going to have to multiply out the full number value for 28 million, right? So far 28,000, add 3 more zeros. There we go. There's your 28 million. So we're going to multiply this amount together. So go ahead and use your calculator. Find that amount. 32 hundredths times 28 million. And so hopefully you're seeing 8,960,000 teens would use that $20 and buy a music CD. This right here is predicting the amount of teens that buy that music CD out of 28 million teens. So we're still taking a small sample. We're taking that small sample and we're predicting to a larger population of what's going to happen. The only difference is from Friday to today is you're using a percent and the decimal format of that to help you find that answer instead of a percentage. Okay. So number 7, let's answer this building on the essential question. I do want to talk about this. And so it says, when can statistics be used to gain information about a population from a sample? And so I keep saying it over and over, like I just did in this last problem, number 6, and in number 8 on the other page. So what we've been talking about is a sample is a small representation of the population. And then we can predict sorry, this is not, again, the best tool, so I apologize if it's a little unreadable here. We can predict from our sample what the population would say. Okay. A sample is a small representation of the population, period. We can predict from our sample what the population would say overall. All right, so let's try a couple more with these percentages. So we're going to go to the next page. We're going to go to independent practice, page 797. So on your screen, it's to the right here. And we're going to look specifically at number 6. Again, last week on Friday, we had done some proportion work based on some tables. Okay, so the independent practice, we had done 1 through 5 here. And again, set up with proportions to predict. Now we're going to use, again, these percentages. So we're going to start with number 6. It says, use the graph that shows the percent of cat owners who train their cats in each category. So you're going to see over here, training cats, the percentage, and then the problem. So they're training, so 43%, this first bar, are training their cats to not climb on the furniture. 29% of this sample, this survey, is teaching or training their cats to not claw the furniture. And then 17% is training their cats to not fight with other animals. Okay, so that seems to be a common problem. And so that's what they're trying to find. What are the most common problems you're trying to train your cats on? And again, this is based on a sample right here. So now letter A says, out of 255 cat owners, predict how many owners train their cat to not climb on the furniture. So we're going to extend this survey out, this sample out, and we're going to predict, if we look at 255 cat owners, not climb on the furniture, these cats. So we're going to focus on this first bar at the top here. Well, if it's 43% that are saying in the original survey that they're training their cats not to climb on the furniture, that is the percentage we're using, and we're going to take that percentage to a decimal. So 4,300, it's 0.43 times. And we're going to predict out if there's 255 cat owners. Okay. So go ahead and multiply that and find out how many out of 255, the larger population of cat owners, are training their cats not to climb on the furniture. So hopefully you're seeing 110 people out of that 255. Okay, so you're predicting out, you're using that 43% on the original survey taken, predicting out to the bigger population of 255 people, and you can predict 110 people out of that 255 are training their cat not to climb on the furniture. Letter B, out of 316 cat owners, predict how many cat owners trained their cat to not claw on the furniture. So now we're looking at the second bar here, and 29% in the original survey said they were training their cat not to claw the furniture. So we're going to use that original survey percent, that 0.29, and we're going to predict by multiplying by our new amount of population, 316. All right, again, try this one. And you should be able to see that 92 people are training their cats to not claw the furniture out of 316. All right. So again, to practice, we're going to take a look. I'm going to have you go to extra practice, which is going to be on page 799. So these are the last couple sample problems we do in the book. And then you're going to head to that worksheet. And so the extra practice on 799, number 15, you have a circle graph off to the right that talks about how often teens volunteer, and it's sectioned off into percentages here. Once a week, once a month, once a year, a few times a year, not at all. And so you're going to use this to predict out for A, B, and C these problems. So I'm going to give you some time to work on those three. Try A, B, and C for me. See if you can correctly predict. Make sure you're reading the question very carefully and the circle graph very carefully. Pause the video, try those, and I'll meet you back with the answers. All right, so take a look at 15A, B, and C. You should have gotten a number 15, letter A, 60,000 teens that volunteer a few times a year if you take the original survey and the circle graph at 20%, 0.20, and predict out to 300,000 teens. Letter B, you're looking at 72,500 teens that volunteer once a week. And so, again, you're using the circle graph at the 29%, the original survey, 0.29, and predicting out to 250,000 teens to see how many would only volunteer once a week. Lastly, letter C, now you're going to use the circle graph to look at those that volunteer once a year. And so in that survey, it was only 3% that volunteer once a year. Now, this is where the mistake could happen. 3% as a decimal is 0.03, right? Two places to the left, not 0.3, 0.03. And so this 300ths right here times the extended out 240,000 teen population, you're looking at 7,200 teens. Okay, we're going to stop in the book. We're going to transition to your worksheet. And I'm going to meet you back in one last video. I'm going to do maybe one or two problems with you and just make sure you understand what you have to do on the worksheet and then get you going so you can work on that the rest of the time. I'll meet you back in the next video.